Welcome to Hexagon Tutorials Dart series. In this tutorial, we will cover enum, short for enumeration, sealed class, reflection, extension methods, file handling, and networking. Let's start with enum. So, what is an enum? An enum, short for enumeration, is a special data type used to define a fixed set of named constant values. Instead of using plain strings or numbers throughout your code, enums give you a clear, predefined set of options. Now, why should we use enums? First, they improve readability and type safety. You know exactly what values are allowed, and the compiler can catch mistakes early. Second, they replace magic strings or random integers that are hard to track or prone to typos. And lastly, enums make your code easier to maintain. If you ever need to change or expand your set of values, you do it in just one place. So, enums are a great way to keep your code clean, safe, and organized. This is how we create an enum in Dart. We start with the enum keyword, followed by the name. In this case, it's weather. Inside the curly braces, we define a fixed set of named values: sunny, cloudy, rainy, and snowy. These are constant values and help us avoid using raw strings or numbers for such cases. Now let's look at the main function. Here, I'm using a for loop to go through all the values of the weather enum. Weather.values is a built-in property that gives us a list of all the enum values. Using weather.values.length, we get the total count, and with weather.values, we access each value one by one. So when we run this code, it prints sunny, cloudy, rainy, snowy. This shows how easy it is to work with enums and how they improve code readability and safety. Let's take a look at how we can use enums with conditional logic in Dart. Here, we have an enum called weather with 4 values: sunny, cloudy, rainy, and snowy. In the main function, we create a variable today and assign it weather.sunny. Now, using an if condition, we check if today is sunny, we print it's a sunny day. Otherwise, we print better grab an umbrella. So when we run the code with weather.sunny, we see the sunny message. But now let's change it. I update the line to weather today is equal to weather.rainy. This time, the condition fails, so the else block runs and we get the output: better grab an umbrella. This is a simple example of how enums make conditions more readable and meaningful by replacing arbitrary values with clear names. Now let's take enums to the next level by adding properties and methods to them. Here, we have an enum called traffic light with 3 values: red, yellow, and green. But notice something special. Each of these enum values has a duration associated with it. Red stays for 30 seconds, yellow for 5 seconds, and green for 25 seconds. To make this possible, we declare a final property duration and then use a constant constructor, const traffic light, this dot duration. This constructor assigns the duration to each enum value. We've also defined a method called display inside the enum, which prints a simple message like red light stays for 30 seconds. Now coming to the main function. In main, we simply call traffic light.green.display. This tells Dart to access the red light enum and run its display method. The result? A clean, structured way to associate data and behavior with enum values. This makes your code more readable, reusable, and powerful. Let's talk about sealed classes in Dart. A sealed class is a special type of class that restricts which other classes can extend or implement it. This gives us more control and safety in our code, especially when we know all the possible subclass in advance. So, why should we use sealed classes? First, exhaustiveness. Since the compiler knows exactly which subclass exists, it can help us catch missing cases, especially useful in things like switch statements or state handling. Second, it's perfect for state management or whenever you're modeling a fixed hierarchy of types like different UI states or API responses. And third, it prevents unwanted subclass from being created somewhere else in your app, so your architecture stays clean and predictable. In short, sealed classes bring structure, safety, and clarity to your Dart code. So here we're exploring sealed classes in Dart with a simple shape example. We start by creating a sealed class called shape. Now, what makes it sealed is that it restricts which classes can inherit from it. This means only specific subclass, defined in the same file, are allowed. This helps us build safer, more predictable code because we know all the possible types that shape can be. Next, we define two specific shapes, a circle and a square. Each of them holds its own property. The circle stores a radius, and the square stores a side length. Now we have a function that takes in a shape and figures out what kind of shape it is. If it's a circle, we calculate the area using the radius. If it's a square, we calculate the area using the side. We then print out the result. In the main function, we create one circle and one square, and we pass them to our area printing function. Based on the shape, it prints out the correct area. The beauty of this approach is that we're using sealed classes to tightly control the types and type checking to safely work with those types. It's clean, clear, and avoids bugs from unexpected subclass or misuse. This is a great setup for building robust systems like UI states, form validation, or anything where you want to define all possible types upfront. In this example, we're working with a sealed class called shape and two of its subclass, circle and square. Now here's the important part. We want to describe each shape differently based on what kind of shape it is. For that, we use a switch statement, and this is where the real power of sealed classes comes in. So let's walk through what's happening. We define a function called describeShape, which takes a shape as input. Now, because shape is sealed, the Dart compiler already knows all the possible subclass. In our case, it knows that shape can only ever be a circle or a square. That's why we can use a switch case statement with confidence. We're not guessing, and we're not writing defensive code. The compiler ensures we handle every possible type of shape. Inside the switch, if the shape is a circle, we extract the radius and print a message like circle with radius 5.0. If it's a square, we extract the side and print square with side 4.0. And here's why this is better than using traditional if-else conditions. First, the code is more readable and expressive. Second, the compiler will actually throw an error if we forget to handle any subclass of the sealed class. And third, it gives us full confidence that we've covered all possible types, no surprises at runtime. In the main function, we simply create a circle and a square and pass them into our describeShape function, and each one is handled correctly based on its type. So using switch with sealed classes is a powerful combination, perfect when you have a fixed number of types and want your code to be safe, clean, and future-proof. In this example, we're modeling a user authentication state using a sealed class structure in Dart. Let's break it down. We start with a sealed class called authState. This acts as the base type, and only specific subclass are allowed to extend it thanks to the sealed keyword. That gives us full control and allows the Dart compiler to enforce exhaustive checks later. We define 3 different states the user can be in. Logged in, this class stores a username and represents a state where the user is logged into the app. Logged out represents when the user is signed out. Loading indicates that some authentication process is in progress, like logging in or checking credentials. Now, let's look at the function handle authState. It takes an object of type authState and then uses a switch statement with pattern matching to determine which specific subclass it's dealing with. If the state is logged in, it extracts the username and prints a personalized welcome message. If the state is logged out, it shows a simple message that the user is logged out. In the main function, we call handle authState with different states. First with loading, so it prints loading. Then with logged out, and it says you are logged out. And finally with logged in, Virat, and we get the output. Loading, you are logged out. Welcome Virat. There's a slight change I made. Earlier the username didn't have a defined type. Now I've added final string username to make it more type safe and clear. In Dart, we have something super useful called extension methods. They allow us to add new functionality to existing classes without actually modifying those classes. It's like giving extra powers to a class that already exists, whether it's a built-in type like string, list, or even your own custom class. Now, why would you want to use them? Well, first, they're great for adding utility methods, like trimming a string, formatting a number, or doing something custom with a list. Second, it keeps your code clean and modular. Instead of writing helper functions everywhere, you simply extend the class directly. And most importantly, you don't need to create a subclass or touch the original class. Just use an extension and you're good to go. So, extension methods are perfect when you want your code to be neat, reusable, and expressive without changing the foundation it's built on. Alright, let's look at a practical example of an extension method in Dart. We've created an extension on the string class and called it string extension. Inside this extension, we've added a new method named capitalize. What does it do? Simple. It capitalizes the first letter of a string. So if the string is empty, we just return it as is. Otherwise, we take the first character, convert it to uppercase, and then add the rest of the string using substring 1. Now in the main function, we have a regular string, hexagon. We call a new method capitalize on it, just like it was built into Dart, and it works. The output is hexagon with the first letter capitalized. This is the power of extension methods. We didn't touch the original string class, but we added our own custom functionality to it, making the code cleaner and more expressive. Let's try out extension methods on integers. We've created an extension called int extension on the int type. Inside it, we added to custom getters. Is even number to check if the number is even, and is odd number to check if it's odd. So first, we test it with the number 8. And the output is exactly what we expect. 8 is even? True. 8 is odd? False. Nice and simple. Now, let's change the number to 9 and run it again. And this time, it says, 9 is even? False. 9 is odd? True. So our extension is working perfectly. We've successfully extended the functionality of the int type, keeping the code clean, readable, and easy to maintain. In this example, we're extending the functionality of the list class with our own custom method, shuffleList. We start by importing Dart math package because we need the random class to perform the shuffle operation. Then, we define an extension called list extension on list T. Inside that, we create a method shuffle list that randomly rearranges the elements in the list using the Fisher-Yates shuffle algorithm. Now in the main function, we declare a simple list of numbers 1, 2, 3, 4, 5. We print the original list, then call our custom shuffle list method on it. And finally, we print the shuffled result. Every time we run this, the list gets randomized thanks to our powerful little extension. This is a clean way to add utility to existing classes without modifying the original list class itself. Perfect for reusable, modular Dart code. Let's talk about extension methods with generics in Dart and how they can make your code more reusable and powerful. In this example, we've created a generic extension on list. That means this method, print elements, can work with any type of list, whether it's a list of numbers, strings, or even custom objects. Inside the method, we simply loop through each item and print it. Nothing fancy, but the power lies in the fact that it works with any list type thanks to the generic. In the main function, we test it with two different lists, one list of numbers and one list of names. Both of them call print elements, and it works perfectly because the method doesn't care what type of data it's printing. This is the real advantage of combining extension methods with generics. You write the logic once and use it anywhere on any data type without duplicating code. Simple, clean, and type-safe. Let's talk about a very important limitation of extension methods in Dart. They cannot access private members of a class. Here's what's happening. We have a class called user, and inside it, there's a private variable called _private_name. That underscore means it's private. It can only be accessed within the same library. Now, we try to create an extension on user, and we want to access that private variable using a getter. But here's the catch, this won't work. Why? Because extension methods live outside the class, and Dart protects private members from being accessed externally, even by extensions. So if you try to run this, the compiler will throw an error saying something like, _private_name is a private member and can't be accessed. The key takeaway here, extension methods are powerful, but they respect Dart's encapsulation rules. Private is private, and extensions are not an exception. Keep that in mind when designing your classes and extensions. And that's a wrap on the Dart series. Thanks for watching. Do like, share, and subscribe to our channel.